everyone, welcome to another YouTube video. And in this video, I'll be talking about the data engineering roadmap and the necessary skill sets to become a competent data engineer or a big data engineer in 2023. Without any further ado, let's go dive into the skill sets required to become a data engineering professional. So based on the various job descriptions that I've seen in various job portals like LinkedIn, etc., I consolidated a list of core competencies required to become a proficient data engineer. And the first most mandatory and important skill required for any data engineer is SQL, that is structured query language. So as a data engineer, your main job is to collect data from various different sources, then apply transformation logics, and then extract business insights based on the required scenarios and execute the output. So if you are very competent and very much comfortable with SQL, then you are like 50 to 60% a competent data engineer. And the next one is Linux basics and shell scripting. So why is it important for a data engineering professional to know about Linux basics and shell scripting? The reason is that many distributed computing frameworks such as Hadoop, Spark, and Kafka, they all work well with Linux servers. So chances are in your company, you will be working with them on a Linux machine. So understanding the Linux basic file structure and how to open, save, and then view your files in editors, and then do some basic troubleshooting, whether your service is running or not, and then run some basic shell scripts to automate some mundane tasks. So it is a good skill to have in your arsenal, that I would say. Then coming to programming languages. So as a data engineering professional, you should be competent with Python or Java, or if not, you should be competent with both of these languages, I would say. If you're new to software engineering and if you come from a non-tech background, then I suggest that you start up with Python because it is easy to pick up and learn. Then once you're comfortable with Python, you should definitely learn Java, because the OOPS fundamentals are important as you go along the data engineering path. And Java is a key language when it comes to object-oriented programming language. Then cloud stack exposure. Basically, in old times, as if you take a data engineering professional, or if you take a look at the software engineering companies, they will have their own machines or servers in their own companies. They are called on-premise servers. So you should be actually installing and running software in your on-premise devices. After the boom of cloud computing, cloud stack providers like AWS, Azure, and GCP offer out-of-the-box distributed computing in their own cloud computing machines. So cloud stack exposure is a very good skill to have if you are starting out as a data engineering professional. Majority of the software service companies are running AWS stack. So if you are just starting out, then I would recommend you start with cloud computing fundamentals, then go on and learn about the various AWS services offered in big data domains, such as Elastic MapReduce, EMR, EC2, S3, AWS managed Spark service like AWS Glue, etc. Then once you are comfortable with a single cloud provider, learning other tools such as Azure Data Factory or tools offered by Google Cloud provider would be easy to adapt. So stick to a single cloud provider. Then once you have mastered a single cloud provider, those skills are transferable, and the learning curve becomes a bit flat at the top. And the next most important thing every big data engineer or data engineer should know is distributed computing frameworks. Hadoop, Spark, and Kafka are like the famous ones, famous distributed computing frameworks in the market at 2023. And you should start with the Hadoop fundamentals and MapReduce. Once you're comfortable with Hadoop, then you should definitely learn Spark, because Spark is one of the most demanding skill set in the market right now. And many companies are leveraging this tool, uh, and I mean this framework, due to its high execution speed and efficiency. And Kafka is a distributing messaging framework. You should at least know about a little bit about the distributed messaging framework as well. And Kafka is the best current in the market. Then data-centric software architecture and terminologies. What I mean by data-centric software architecture is that you will, once you're a data engineer in the software industry, you will hear a lot of jargons like ETL pipelines, ELT pipelines, Lambda architecture, Kappa architecture, etc. So these things you will learn more and more when you get a job, and as you gain more experience. Even still, you could go through some data engineering books, or learn a bit about event-driven design for your own understanding. And having a good basic foundation of data-centric software architecture will definitely help you set the correct practices and standards in your project. And it is good to work in a software project with good standards and maintainability. And these software architecture basics will help you design applications that are scalable in the future. And NoSQL databases. So SQL databases basically means structured query language. NoSQL means they don't have a structure. Some of the popular table databases are DynamoDB, MongoDB, Cassandra. So these tables are built based on the CAP theorem. There is actually another video about distributed systems in my channel. And if you want to learn more about CAP theorem, you can check out that video. I've given a detailed explanation about that. And the next one is data orchestration tools. See, you can ask me, like, if you just mastered Linux basics, there is something called a cron tab, where you could just schedule mundane tasks or jobs that you need to run every day or in a given periodic fashion. The thing is that as a data engineer, there are many moving parts to a data pipeline job. You have to collect data from multiple different data sources, then you have to bring them to a single place, clean the data, apply transformations, and load the data at an endpoint or a streaming service like Kafka or an API, etc. So yeah, if you ask me, is it possible to schedule all these things in a single script through a cron job? Yes, it is possible. But when something goes wrong, or if your service goes down, then like troubleshooting the issues and looking at the logs, cron job becomes very cumbersome, and finding where things went wrong, it is very difficult to debug in if you're using only a cron scheduler. So that is why data orchestration tools like Airflow, Oozie are very popular in the market. And as a data engineer, you must know what these are and how to leverage these things to schedule your data engineering jobs in your big data pipeline. So the basic overview of the skills are done, and then one by one, I'll go into each and every single skill and tell you what all you should definitely know about them. So first, I'm taking up SQL. SQL is basically a structured query language. So it basically works on creation of databases and tables. So if you are having SQL as a skill, you should definitely know how to create databases and tables. Should you should know how to apply basic commands and queries like select data from a table, apply where clauses to filter data, then apply aggregating functions, how to group your data, then how to order by data, then how to use in and between to select a range of data from your table. Next, the most important thing is that you won't have your data in a single table, like in production or whatever software engineering project. There will be multiple data tables in your database, and more than often you have to join these tables to get your desired transform result. So you have to be a master with joining tables, whether it is left, right, inner, outer, or joining the same table and performing a self join. Then you should know about case statement, doing windowing functions and running subqueries, that is a query within a query, to provide some optimized transformed results. And finally, you should know about the basics about disaster recovery in case if your database server goes down, how to recover the table from the given raw data. And for Linux basics and shell scripting, you should know about the Linux file structure. You should know about the shell terminal, the basic commands for creating and navigating files. You should know what a touch command is. You should know what a cat command is. You should know how to delete files. You should know how to copy and move files. Setting up small cron jobs for running some shell scripts time to time, and network management, monitoring services, and troubleshooting. This part, I won't recommend that you should know each and every detail, but it is good to know because the chances are in a production environment, you will be working with a distributed Linux machine, because as a data engineer, you will be working with distributed frameworks, obviously. So in such a situation, you might have 3 to 4 Linux machines connected in a distributed environment. And in case if your job fails, it is good to know what services are running and which nodes are up. Just the basic level of understanding would be very helpful for you to debug in scenarios in case when your data pipeline fails. Next, the main thing for a big data engineer is the proficiency in distributed frameworks. So, based on the current data engineering and big data engineering market, Spark, Hadoop, Kafka, and HDFS are the popular distributed data frameworks available. So initially there was Hadoop, which is the Hadoop distributed file system. So this is a very popular file system used in the big data domain. It is mandatory that you know how to store files, delete files, and move files in the Hadoop distributed file system. You should definitely know about the Hadoop architecture, such as creation of name nodes, data nodes. I mean, what are data nodes? What are name nodes? What is data replication? What is heartbeat, etc. You should know about the MapReduce framework and how to create simple programs using the MapReduce framework. Although currently many people are writing applications for Apache Spark, you may think that MapReduce might be very redundant to learn at this point of time. The thing is that MapReduce was the base of distributed computing. So it is always good to understand the fundamentals and where it came from. So I recommend that you have a good fundamental understanding of MapReduce framework. Next is Apache Hive. Hive, you can consider it as a querying language run on the distributed files in Hadoop distributed file system. So basically, it will be just like your RDBMS, but It is not a database management system, but you could run SQL-like queries in Hive and then get the transform results. Apache Scoop is a tool to import and export data from HDFS file systems to RDBMS. It is a very important tool that I would say that you should definitely know. Only like 4 or 5 commands in total it will be there, but it is a very useful tool. And as a data engineer, chances are you will be working with it almost like uh, at least once in a week, you'll be exporting or importing data from various data stores. Apache Spark. Currently, uh, this is the most fast and most efficient distributed data computing framework in the market at 2023. So you should know about the various installation modes in Apache Spark. You should definitely know about the Apache Spark architecture, and you should know about its structured APIs such as RDDs, resilient distributed data sets, data frames. Uh, Currently, data frames are becoming more popular than RDDs, but uh, internally, data frames are actually RDDs. Uh, a detailed lecture will be given on the difference between these two in another separate video. I'm just stating them briefly here. Then Spark SQL, that is also similar like Hive. Spark SQL is also very useful in transforming your data. Then you should know about how to optimize your Spark jobs and how to tune them. You should know about the streaming capabilities of Spark, applying windowing functions, aggregating streaming data. Then how you deploy Spark applications in a production kind of environment. And the next one is Apache Kafka. Apache Kafka is a distributed messaging system. So it is a loosely coupled messaging system, one can say. So what I mean by that is that if you're producing data, this data will be produced to a common location called a broker where you'll have topics. And this topics, the data that is stored in the topics can be consumed by various consumers for various teams and various applications. And they do not have any dependency with each other. That is the main advantage of having a distributed messaging system. And with this, you could scale up to millions of messages easily in a production environment with little to no bottlenecks. And for this, you should definitely know about the installation procedures for a local development environment and how to do production grade deployments in a Linux machine. You should know about the architecture, the understanding of producer and consumers and the associated properties with it, and the design considerations when you're creating a producer or consumer client. Then you should know about security and authorization. And with authorization, I mean, you will have existing systems such as Active Directory, LDAP, and RBAC. And how do you integrate them with Apache Kafka? Then how do you do performance tests? How do you load test your brokers? And how do you throttle your producers? How do you throttle your consumers, etc.? And software architecture and terminologies. As a data engineer or big data engineer, the more experience you gain, the better you'll be understanding software architecture and designs. And you'll learn about a lot of these at your job or by doing hands-on practices. But still, it is good to know a few terminologies when you're starting out. So you should know what Lambda and Kappa architecture, data lakes, warehouse, data mart. You should definitely know what an ETL pipeline is and what is an ELT pipeline and what is the difference between these two. You should know what change data capture is. You should know about data replication and the basics of disaster recovery design. Disaster recovery design would be done by data architects and along with DevOps engineers, but still it doesn't hurt to know about disaster recovery design, and you should know about how to scale your big data pipelines. Chances are, when you're building a data pipeline or a data job or an ETL pipeline, uh, after a few months, the volume of data is definitely going to grow large, and you will definitely hit a bottleneck at a particular point, and you should know what design constraints are there, and in case if a bottleneck is faced, then how do I scale my application? You should know how to scale your application, and with minimal changes to your code and existing jobs. And NoSQL databases, NoSQL databases, like uh, mostly backend engineering, software engineering teams use NoSQL databases due to the ever-changing schema, and uh, since there is no structure in NoSQL, it is easy to update and transform your schema along with having backwards compatibility. So chances are, in your ETL pipelines or ELT pipelines, you have to apply transformations on large volumes of disparate data sources. And once that data is transformed, you might be hitting an API which uploads data into a NoSQL database like Cassandra or MongoDB. So uh, you should definitely know whether the NoSQL database is receiving data from your big data warehouse or data mart, and you should be able to query data on a particular date range. And scaling NoSQL databases, it may sound a bit out of topic or out of scope, but it is definitely good to know how do you scale a NoSQL databases and its design considerations. And you should definitely know the significance of CAP theorem and its design considerations. As a data engineer, you'll be working with distributed frameworks, so you would definitely be knowing what CAP theorem is. So, and how does this CAP theorem apply to NoSQL databases? That part also you should be having knowledge about it. And finally, for data orchestration tools, uh, the current popular data orchestration tools are Apache Airflow and Uzi. So these orchestration tools are built over the DAG principle, that is direct acyclic graphs. In simple terms, what a direct acyclic graph means is that the starting point is not the same as the ending point. The starting point is the same as the ending point. It is a circular graph. So based on this principle, you could schedule various tasks and modules in a single direct acyclic graph for automating and scheduling your ETL or ELT pipelines. And using these tools, you will be able to schedule jobs, and in case if there is a failure or fault, you can easily debug them using the log stash given by them, or using the UI tools as well. So this is an overview about how to become a data engineering professional and the required skill set. And this is the complete roadmap. And each and every one of the skills that I've listed here, I'll try to cover them as much as possible in my YouTube videos, so that I could share my knowledge with you guys, which can be helpful for you in your job or cracking interviews. So if these are the skill sets that you're interested in, then do subscribe my channel, as I'll be uploading them regularly over the course of time. And I'm pretty sure it will be helpful for you guys in your preparation. Stay tuned for more videos.